We are going live, folks. Brian, you may not be able to share because I've got the spotlight turned on me right now.
That's okay.
Okay.
It'll work one way or the other.
Yeah, we'll get you going.
I
Yeah.
saw it briefly. I saw it
I
briefly
did
in
too.
here.
Yeah.
I just
There,
popped it up for a couple
it's
seconds and
there.
then you said we're going live and I turned it
Oh,
off.
okay. Okay.
Yeah.
It's
Yep.
not.
Then you're good.
And Terry, just so you know, it's pretty much the same prezo as last month with some new updates based on some of the developments in the last few weeks.
Okay. Sounds great.
There's weird stuff out in space, man.
Colorful.
That's right. Hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance, and Terry Mann with the Astronomical League. And this is Astronomical League Live number 54. Is that right, Terry?
54. Yes, it is.
Okay. All right. So you have
Yeah.
a special guest on tonight and some great speakers overall. So I'm going to turn it right over to you.
All right, Scott. Thank you so much. Yes, we have a great lineup tonight. We have Jericho Kuehl from Milwaukee that will be our keynote. He is a 17-year-old high school senior and is doing amazing work. We have Don Knabb, which is the Mid-Eastern Region Chair of the Astronomical League. We have John Goss, which most of you know John from all of his postings that you see on Facebook. He does miracles with graphs. And we are really honored, too, to have Brian Simpson, the president of the Cincinnati Astronomical Society, joining us. All right, so let's go ahead and get started. Let's start with John Goss. You're dressed for it.
Yeah, thanks, Terry. Thanks for having me, by the way. Uh, I'm all dressed here, something special because in 2 weeks we roll into the December solstice,
Ooh.
shortest daylight time of the year. So be aware of that. And this is a good time to celebrate. Go outside and bang on your solstice drum to bring back the warmth and the sunlight of summer, which is hopefully, well, it's 6 months away, however you look at it. But anyway, I want to say a few things tonight. Um, the subject of my talk is how that came about. I'd like to say a few words of something that probably people will want to strangle me for, but I'll utter the words T. corona borealis. We've been saying for 14 months, more than 14 months, any moment, this baby's going to go off. We're going to have a nova in our sky. And of course, that hasn't happened. When October rolled around and Corona Borealis was setting in the northwest fairly early, you start thinking, probably in another month they're going to have that nova when we can't actually see it. But now we're in such a time of year in which Corona Borealis rises. It's high enough to see at about, oh, from where I live, 5 a.m., 2.5 hours before sunrise. So you will be able to see it if need be, and of course you need clear weather. But as the seasons go on and the days go on, it'll rise earlier and earlier. So I still have my fingers crossed to see it. The reason why I bring it up, T Corona Borealis. Well, we're all just kind of scratching our heads, keeping our fingers crossed. But I'd like to share my screen here. I know I shouldn't have to say that because I have to keep myself in track of what I'm doing. Thank you, John. There we go. I'd like to start by saying, since Jericho's going to speak a little bit about citizen science, I'm just giving a plug for the Astronomical League citizen science programs, a whole bunch of them. You can see a whole bunch right here, and this is just some of them. This is probably about half of them. It's all I can really fit on the screen. But if you're interested in this type of activity, here's the great website to go to on astroleague.org. Go to Citizen Science Special Program, and you will see all these different programs. You can click on it and see how you can get involved with that. So if that's your cup of tea, go ahead and try it out. Try it out. Okay, Johnny. Now what's wrong? There we go. So T Corona Borealis is a big iffy thing in the sky, but I got something that's guaranteed to appear, to reappear. 34 Tauri returns after 84 years. How do I know that? How can I guarantee that? How do I know what I'm talking about? That's a good question. Let's move on. Let's review a little bit about star maps and a little bit about history and so on. You might be familiar with this Flamsteed numbers of designating stars, which all it really is, stars that are bright enough to be seen with the unaided eye are given a number in each constellation, beginning with the star most visible that is furthest west. And as RA increases from west to east, the numbers increase accordingly, such as in Taurus, we got Omicron Tauri, which is down in the lower right. That is number 1 Tauri. Xi Tauri is right next to it, number 2. You go through a bunch of stars, which I'm not going to list off because we're going to come to star number 32 and 33, which are just to the lower left of the Pleiades. Then on to 35, you can see it as Lambda Tauri, and then a bunch of others, 36, 37, and there's 38 someplace, which I didn't list, and 39. In fact, Taurus has, I believe, 140 stars in it that you can see with the unaided eye. That might be the most of any constellation, at least any in the northern hemisphere. So you immediately think, well, where's number 34 Tauri? What happened to it? It's not there. What's going on here? Well, Flamsteed made an atlas, and he started on doing this, I think, in the year 1690. Now, it says 1795 on the screen, but this is a re-edited, redone version of his atlas in 1795. Now, I'm bringing this up because I want to show you a few things on it. So we zoom in on the center between the Pleiades and the Hyades, Aldebaran region. You will see that there is an indication, a mark on the map called Herschel. Herschel is the name of the planet it was given the name of the planet that William Herschel discovered before people really settled in for the name Uranus. So in 1690, when John Flamsteed made this map, the original version of the map, he saw a star, what he thought was a star, where the Herschel designation is on this map. And that happened to be the 34th star in Taurus. So 34 Tauri. This is pretty much what he saw. There are a number of other fairly bright stars around it. There's 32. Remember, 33 was down to the bottom of the page. No, I think that was 33. They got 34 and 37 and a bunch of others in there. But if you were there standing next to John Flamsteed on December 23rd, 1690, this is what he would have been plotting on his map that he was developing. Okay. So here it is today, or here's the situation today. Let's see if we can start out on this. So you can see we got the retrograde and prograde motions of Uranus. So let's zoom in on that and I'll explain it a little bit more. Tonight, over on the right-hand side of the chart here, you can see a little green dot. That's where Uranus is right now. And over the next month, over the next 7 weeks, it progresses further west until about the 31st of January. And it stops, slows down, stops, and reverses direction, becomes more prograde. That is in the direction that it would normally take. Goes chugging along until about June 11th. Now, June 11th is special, and simply because that's about the same location that John Flamsteed saw Uranus when he marked it off as 34. Continue on to September 9th of this coming year, and then back into retrograde, comes into opposition in November 25th. But on December 19th, that's the date we really care about, because that date, that position on that date matches up fairly well with what John Flamsteed saw on December 23rd, 1690. Continue on in retrograde until February 5th of next, or a little more than a year from now. And then it goes prograde again, chugging back again. And actually, there's a spot right here, which I didn't mark because everything's too close together, but it's March 30th in 2027. It again hits that same spot in the sky and continues on and so on, out of range again. So on December 19th, 2026, Uranus sits in the spot of 34 Tauri, reappearing again. How often does this happen? Well, Uranus orbits the sun in 84 years. So every 84 years, just for a few days, this happens. Of course, you got the December 23rd, 1690, which was Mr. Flamsteed's observation. And he could have done it again on March 16th of 1691. You can see then the intervening years, every 84 years, there are 3 times which it can be seen like this. Last time was in 1942. But now we're coming up to the 2026 versions of this. So on June 11th, you really can't see it on June 11th because the sun is in the way. So forget about that. But December 19th, it'll be just about the same spot where it is now, or where it will be December 19th. And then March 30th, as it comes back again, loops around, it comes back, it'll be in about the same spot. If you miss that, you're out of luck until 2110. So keep that in mind, because here you are. What I like about this, I'll go into a little story here, is that I was snooping around just about what's happening with Uranus, snooping around a few months ago, and I came across that, hey, here it is. Right now, it's fairly close to the Pleiades and fairly easy to find if you got a little star guide. And then I knew about 34 Tauri and that John Flamsteed designated Uranus as that. And I thought, well, maybe we can find it. It'll be in about the same spot. So I started making a flyer for this to show people how to do it. Then I realized, no, wait a minute. I'm a year early. It should be in December of 2026, not now. So I'm jumping the gun with all of you right now about this. But this will afford you an excellent opportunity to essentially confront history. You can relive history in December of next year by finding 34 Tauri, which is Uranus, and seeing something similar, very similar to what John Flamsteed saw. So here you are, in 1690 with 34 Tauri, to Flamsteed, it appeared very starry. But for the rest of us, it was a planet, Uranus. So there you go. Get out and observe. Thank you, Terry. Any questions on that?
No, but
Will
I
you
think
remind
that's
us again next year?
I'm sorry, Don, was that Dawn?
Yeah, will you remind us again about this next December, please?
Well, yeah, I'll try to. It's on my calendar already, believe it or not. So it's a little bit of history.
yeah, that's pretty interesting, really.
Mhm.
That's
Mhm.
there
and-
really are,
And here we are talking about T Corona Borealis. Is it going to happen or isn't it going to happen? Well, I can guarantee you that 34 Tauri is going to reappear in next December, at least for a few days. So
Yeah,
Keep
we,
that in
we
mind.
like those guarantees. Those
Guaranteed.
make it, yeah, that's nice. So thank you, John. That was really interesting. And
You're
yes,
welcome.
we would love to have you back in December of next year, and you can talk about that then too. But yeah,
Well,
that's an
you have me
interesting
back in
idea.
January so you can skin me alive if it doesn't really happen. So
There we go. Thanks, John.
you're welcome. Thank
All
you.
right. How about now if we go to Don Nab? Don, I tell you every time you're on, I really enjoy the presentation that you do.
Nice.
It really brings the night sky and what we can see and what's up there so much closer and makes it easier because of the way you explain it. So Don, thank you for being here. We appreciate it.
All right, you're welcome. Let me share my screen. And I'll start my slideshow. Okay, coming through okay?
Yes.
Let me hide this floating meeting control. There we go. All right, so December night sky took a little bit different tack this month because we were just on here 3 weeks ago. So I am going to show what great John Goss gave to us for December because this is our Christmas present from John. I'm not going to spend a lot of time because I did that 3 weeks ago, but the December sky map with a walk through the cosmos down here at the bottom. He points out binocular highlights. So again, we just did this last few weeks ago, so I won't do it again. Over here, oh, I skipped one, two. Over here is the morning sky. And down on the right, the third one for the month was evenings in December and January, a challenge to see Jupiter moving in retrograde. So these are great. You can download them from the Astronomical League website and hand them out to your friends and family for Christmas. Give them the heavens for Christmas. You can't beat that, can you? So lunar highlights, new moon. Well, full moon was last night. I hope some people went outside to see this. I actually was just finishing up putting up my Christmas lights, and that biscuit colored moon was rising over the horizon. It was just stunning. So I had to stop what I was doing and stare at it for a little while. So that was last night was the full moon, the full cold moon as it's called, or the river's freezing moon. New moon is December 19th. First quarters at the end of the month, 2 days after Christmas. And I'm going to point out one or two really wonderful things to see in the night sky. So about 9 o'clock on the day after Christmas, we can see the lunar X and the lunar V. So if you haven't seen these, set up your telescope. And you'll need a telescope. These are too small to see with binoculars, unless you have really big binoculars. But lunar X is, these are just, I won't call them imaginary, but they're not real. They're not really an X. They're not really a V. It's the way the sun catches the top of the mountains as the terminator is the line of lunar sunrise. So down here, about a third of the way down is lunar X, and a third of the way from the top is lunar V. The next night then is lunar straight wall. So if you got a telescope for Christmas, be sure to set it up and look for the lunar straight wall. It's very distinctive feature, only visible for 1 day or so during the lunar month. And don't miss the Gemini meteor shower. This is a good year for the shower. The moon won't rise until after 1 a.m. and it's only it's a waning crescent, so it's not going to interfere too much. I like to go out early. The radiant is up fairly early, and my favorite ones to see are the Earth grazers. These are meteors that come and just skip through the atmosphere at a very shallow angle, and they can go halfway across the sky. So this is going to be a great year for the Geminid. I'm hoping we have clear skies. Could be up to 120 meters an hour. Best viewed in the pre-dawn hours. So now I picked out, rather than going to any one thing in depth, I picked out the best thing to see that Santa has brought you some new astronomy equipment. So first ones up would be Jupiter. And when I look out about 8, 9 o'clock right now in the evening, Jupiter is shining like a beacon in the eastern sky. So don't miss that if you got a new telescope or binoculars. Saturn continues to rule the evening sky, so it's high in the south. The Thanksgiving night, our neighbors asked me to set up a telescope to show some of his family, and they were thrilled by seeing Saturn. It didn't look like this. It was actually a straight line because the rings are at such a shallow angle to us right now. It looked like a ball with a line through it, but it was a lot of fun. So put Jupiter and Saturn first on your list. And then I'm going to go through some of the most dramatic and beautiful things in the night sky right now. So, of course, M42 down here in the Sword of Orion is a great thing to show anyone in your family. They would enjoy seeing it. And this is probably, for me, the most spectacular thing to see in the night sky, other than like a lunar eclipse or something. But yeah, the Orion Nebula is absolutely amazing to see. We're going to stick around the area of Orion for a little bit. Going to pop up to the Pleiades. I did take this picture of the Orion Nebula. I did not take this one. This is a NASA picture, European Space Agency, and the Pleiades is. You probably need binoculars for this, not a telescope, because it is so big you won't fit it in your unless you have a very, very wide angle eyepiece for your telescope. It just won't fit in your eyepiece. So look for the Pleiades. They are the nicest little cluster in the sky. And there they are up at the top above the Hyades. Not far from Uranus, as John was just talking about. And then one of my favorites, not as big or bright as some of the other ones, but the 37 cluster. This is NGC 2169. Up where Orion is holding his club. And it's hard to see in this picture, but when you see it in the eyepiece of a telescope, it's very distinct. Here's a 3, and over here is a 7. So it really looks like a 37. Now, depending, of course, on your optics, it may be upside down, it may be backwards. But if you have big, heavy-duty binoculars, this is how you would see it. Telescope's probably best to see this. It's a fairly small object. But it's a lot of fun to share with people and say, here, look at the 37 cluster. And there it is up at the upper left of Betelgeuse. Then we have the shoe buckle cluster. Now, this is in Gemini the Twins, right around the foot. I was wondering whether this was named shoe buckle cluster because it's so close to his foot. But from what I read, it's just because whoever named it thought it looked like the buckle of a shoe. I'm not sure I see that over here in the picture of it, but okay, if that's what they call it, that's what they call it. At least that's how it's labeled in Stellarium. But this is a big, bright, open cluster. You can see it in binoculars or a telescope. And here's the one we just saw, 2169. So we're going from the Orion Nebula to the Pleiades to 2169 and over to M35. Talked about this last month, so I won't spend much time, but the 3 open clusters in Auriga are a lot of fun to look at. Easy to find. You have bright Capella, one of the brightest stars in the sky. You go down from there, over a bit to the right, and you'll see all 3 of these clusters. And then we can't leave out the Andromeda Galaxy, our sister galaxy. It's not hard to find if you use the Great Square of Pegasus. Start with this star, and interestingly, this star is actually not part of Pegasus. It was moved to the constellation Andromeda. I still call it the Great Square of Pegasus, like everyone else does. But you can start here, go 2 stars up, and then 2 stars over, and there is Andromeda. Or go to Cassiopeia, take these 2 stars, treat them like an arrow. So there's 2 ways to find Andromeda, and this can be a binocular or a telescopic object. Triangulum Galaxy. Now, this will be, won't look quite like this exposure that I have here that I took with my C-Star, but it'll be with a good clear sky and a reasonably large telescope. You will see some fuzzy structure of it. It's just nice to see it. It's not far from Andromeda. It's an easy hop over to find Triangulum Galaxy, M33. On the double cluster, I can't leave out the double cluster. We did talk about this last month because John had highlighted it in the graphic he puts out. Right in here is that little cat's paw asterism that I talked about. Right in there. Some people call it's upside down now. Some people call it the parachute man, the parachute at the top, the man at the bottom. Double cluster is not hard to find. Again, between Cassiopeia and Perseus, with binoculars, it will jump right out at you, right out at you. Even the telescope it's a beautiful, beautiful pair of clusters in the sky. And there it is. And then one of my favorites, this is a go-to object for any star party, is the Dragonfly cluster or the Owl cluster or the ET cluster. Especially if there's kids around, I like to show them. So here's ET's eyes, there's his body, his arms are held up over on both sides of him, and his legs are down there. It's a better, I like the dragonfly idea. Eyes of the dragonfly, the wings of the dragonfly, and the tail. But again, another beautiful cluster to see. Not hard to find. Once you find Cassiopeia, it's easy to star hop over the dragonfly cluster. And the beehive, this will be arriving a little bit later in the evening. Most of these stellarium maps I set in for December 15th around 9 o'clock. So it'll be a little lower on the horizon in the east at that time of night, but not hard to find. And this is definitely a binocular object. You can see I barely fit most of it in the frame of the sea star. The beehive cluster is something to point out with binoculars. And since we talked about the beehive cluster, we'll talk about the little beehive. So here is the little beehive. This is beneath Orion, near the brightest star in the sky, Sirius. If you're looking for something a little bit more obscure, up here above the nebula is the Kolkar cluster. That's a fun little open cluster. It's only about 7 or 8 stars. Some people say it looks like a coal car. Some people say it looks like a dog. Some people say it looks like a crocodile. But you're looking at the Orion Nebula, just go up above it and find the coal car cluster. So the little beehive, that does fit in the eyepiece of a telescope. It's much smaller than the regular beehive, but it's worth looking for. So that's all I had. Those are the things to look for if Santa brings you a new telescope or big binoculars. So get on some warm clothes, get out there and enjoy the crisp, clear December sky before we get that bone-chilling cold of January and February. Let me.
Well, thank you, Don. I got how much clear skies have you actually had? I know you go between your home and your vacation home. Have the skies been pretty good for where you're at this year in the fall?
Not great. We had a pretty good run in October, September, October, because we had so little rain. It was extremely dry here in southeast Pennsylvania. So we had a lot of good nights then. 2 weeks ago was up in the Poconos, and it was a good night, but it was like 27 degrees. I don't last long. At my age, I don't last long in 27 degrees anymore.
Yeah.
But I did get out and had some fun. Looked for a lot of those things they talked about. Of course, I couldn't leave out Caroline's Rose. That's one of my favorites up there near NGC 457. Caroline's Rose is so beautiful. But yeah, so I've done some observing, not as much as some years probably.
Yeah. Yeah. We did have a stretch there of clear skies in Ohio too. So, all right, Don, thank you very much. Appreciate that. And from Don, I think we will go to Brian Simpson. He is the president of the Cincinnati Astronomical Society, and they are the host club for Alcon 2026. So, Brian, I know it's been busy and you've been working hard, the whole crew. We've got Lori and Eric co-hosting Alcon. So tell us what's going on.
All right. Thanks, Terry. I appreciate you having me on tonight. Let me go ahead and pull up a little bit of a deck that I've put together for our audience tonight. It's pretty much the same as last month, but we've got a couple little developments with some more detail. And let me know if you guys can see that okay.
Yes.
Okay,
great.
And so I usually start this off by giving a little bit of a background of our organization. The Cincinnati Astronomical Society is one of the oldest and largest amateur astronomy organizations in the United States, and we were founded in 1911 by Dr. Delisle Stewart, who was a PhD out of Carleton College, Minnesota, and he spent a lot of time on the Harvard College staff, mostly down in South America and Peru. And Harvard was really an early adopter to the forefront of astrophotography in the late 1800s, and he was very active in astrophotography. And in the early 1900s, he moved to Cincinnati with his family to take a position on the staff at the Cincinnati Observatory here, which I'm sure many of our viewers are familiar with. And so he was there for a few years, but he had a little bit of a problem getting astrophotography implemented at the Cincinnati Observatory. It was not well received by the director of the observatory. So in 1911, Dr. Stewart decided to split off and form his own organization, his own amateur organization that was going to be very focused on doing public outreach and advancing astrophotography. And so that's really sort of our origin. And today we have around 375 memberships in the organization, and we own 3 properties. We own a headquarters on the west side of Cincinnati with observatories, which has been there since Dr. Stewart had established CAS. Him and his family actually lived on the property there over on the west side of Cincinnati. And over the years, we've acquired 2 other properties, 2 dark sky sites, for our members to be able to go and do night sky observing, since obviously we have the same problem as every other urban area does with light pollution. This is our headquarters over on the west side of Cincinnati, and our telescope field, which sits behind. I'll tell you a little bit about our telescopes here. We've got a 14-inch Newtonian and a 16-inch Newtonian, both of which have been refurbished this year by our instrument committee and had new mirrors refinished. The 16 was taken apart completely and completely refurbished. They've done an amazing job on that. We also have a small observatory, which we call the Henkel Observatory, which is named after the man who donated our 1880 Alvin Clark 8-inch refractor. And so we have that beautiful piece of hardware that we use for our members and our public events. Very popular for solar observing at CAS. And then we do have the 2 dark sky sites on the left there, Adams County, Ohio, which we've owned since 1993, and Bracken County, Kentucky, which we've owned since 2015, which also includes a 20-inch reflector in that observatory there. And that was donated by a couple of our very generous members, Steve and Sue Rissmiller, who retired and moved to Florida and bequeathed it to the society. So we're very, very, very fortunate. Just to give you an example, again, give you an idea of the kind of activities we're involved in, we are very, very dedicated to outreach. And in 2024, we totaled 68 events around the Cincinnati area, and that included 15 eclipse prep events. As you are all aware, Cincinnati was right next to the path of totality. In fact, Cincinnati just missed totality by a couple of percentage points. So our goal was to make sure everyone in the area knew that 99% was not enough for a total solar eclipse. And we were very successful in being able to get people to move 15 minutes to the west of Cincinnati so they could get into totality. And in 2025, we are on track for over 60 events. Again, we have a very active outreach team, and that is part of our mission. We also have a very active citizen science program. This is something that is redeveloped over the years. We had a very active Operation Moonwatch program here in the 1950s. We actually have a Ohio State historical marker at our headquarters to designate our participation in that. And over the last few years, our members have really risen up and re-engaged with citizen science. We've got the Radio Jove program, the SID program, and the Exoplanet Watch program that have been really activated among our membership over the last few years. It's making great headwaves within the society. So that is a little bit of an overview of CAS in general. So let's talk about the Alcon. So the Alcon is set to go off next August 12th to 15th, 2026. We actually will be having this right across the Ohio River from downtown Cincinnati at the Marriott River Center in Covington, Kentucky. It's a beautiful facility. We're very, very pleased that we found this location, that it was available. This is the Marriott River Center here. Here is the interior of the building. It's very, very nice. A lot of amenities inside of the building. Here is a meeting space, a wonderful meeting space, which we will use. There's also a big ballroom, which I don't have a current photo of, which I will hope to have one of those for next month. Here's the view outside of the hotel looking across the river into downtown Cincinnati. And there's another wider angle shot of the panorama of downtown Cincinnati with our historic Roebling Bridge in the foreground there. Of course, as usual, Alcon will have speakers. We will have happy hours, and we will have the famous Starbecue, which we now have a little more information on. So there'll be some great speakers, which I'll talk about in a moment. We want to make this a bit of a party, so we'll have happy hours and all sorts of things. Our speakers include Scott Harrington, the contributing editor of Sky and Telescope. It also includes Jericho Kuehl, who is one of our speakers tonight. We're very, very pleased that Jericho is going to be attending Alcon 2026 and doing a presentation there. Of course, senior at Star Ridge Academy, winner of the Horkheimer Daria Youth Service Award. So we're really pleased for Jericho to be coming. We also have Pranvera Haiseni, PhD candidate in planetary astronomy at UC Santa Cruz. She's also known for being the founder of Astronomy Outreach Kosovo, very successful program in Kosovo, establishing their first observatory of their amateur observatory over there. She's also a Celestron ambassador. And we have as our keynote speaker Rebecca Williams, who is a deputy principal investigator for Perseverance MASTCAM and MARDICAM's Senior Science Planetary Science Institute. I know Chuck Allen is extremely high on Rebecca Williams and her ability to deliver a wonderful presentation to an audience. We're very excited to have her. Just to give you a little bit of an idea what the conference format is going to look like, we're doing it a little bit different this year. We're going to have a soft start on Thursday morning. And basically what we're doing there is we're going to just sort of ease into the Alcon Thursday morning. And the idea there is there are so many larger cities within a 4-hour drive of Cincinnati that we would like to give people an opportunity to drive in that morning from those cities and not really miss a whole lot before the conference really kicks into gear. And then that way they can save a little bit of money on the hotel and then put that money towards some of the other activities that we're planning. Thursday, the conference, Thursday afternoon, the conference starts in full at 1 p.m. Friday, we're going to have a split day, and I'll explain what that means in a moment. And then Saturday, we will have an all-day program at the Marriott. So some special events to call out. On Wednesday night, August 12th, we will be having a happy hour at Molly Malone's in Covington, which is just a couple of blocks from the Marriott River Center. We have the entire second floor reserved for this happy hour. This is the night before the conference starts. So if you're coming in early to Cincinnati, or if you live locally, certainly you're going to want to join us for the happy hour at Molly Malone's. We have that reserved. And then on Thursday night is the Starbecue, and we now have secured the Starbecue at the Cincinnati Museum Center. And this is a really, really special place. For those of you who have never been to Cincinnati before, this is a fantastic place just to go and visit. In fact, we had it on our list of places you should visit while you're here anyway. But now you get to go to the Starbecue at the Cincinnati Museum Center. The Museum Center is one of the most fantastic examples of Art Deco architecture in the United States. It's a former train station. It actually still is an Amtrak station, but it is a form. Its primary purpose was to be a train station. It is absolutely stunning and gorgeous. Here is a photo of the interior of the main dome area. Here is the main area inside where the ticket booth and so on and so forth is. It is absolutely stunning. If you've never been here before, I highly recommend taking advantage of the Starbecue. We will have the event in one of the wings of the museum center. We'll have access to all of the different areas of the museum center, including the Neil Armstrong Museum that is built in there. There's a lot of dinosaurs. There are some other really cool places you can explore and adventure within the museum center. A lot of, like I said, dinosaur bones and fossils. Excuse me. And that's Thursday night, August 13th at the Museum Center. There will be food and beverage there, of course, and we will also be offering an IMAX option for people who want to purchase tickets for the IMAX movie. It will be an astronomy or space-themed movie. We're not sure which one yet, but it will be that will be offered for the Starbecue. Okay, Friday afternoon, we're going to do something a little bit different. We're going to have a split day where we have morning sessions and evening sessions. But in the afternoon, we're going to have what we call a discovery day. And we have set up already 2 special activities for guests of the Alcon. You would have to pick one or the other. One is a visit to our friends over at the Cincinnati Observatory, very historic observatory. So they are going to be hosting folks who want to go over there. We are arranging for transportation for those of you who are coming from out of town as well. And there is also a Cincinnati Underground Brewery tour planned with a dinner afterwards at Northern Row Brewery. Cincinnati has a long heritage of breweries in downtown Cincinnati, and there's some really great literal underground tunnels that you can go to see where the loggering took place. We will also be offering some ad hoc options. Those are all to be determined for folks who don't necessarily want to take either of those first 2 options. So that'll be Friday afternoon, August 14th. Saturday evening, of course, is the banquet and the awards presentation, and then the keynote presentation by Rebecca Williams. That is in the Marriott River Center Covington Ballroom. That's where most of the other activities and presentations will be taking place. There is one more activity that we are planning, which is sort of off the board of what you would normally see at an Alcon, and that is Sunday, August 16th. We are going to have an after party, and this is going to be hosted by our organization, Cincinnati Astronomical Society. This is not technically part of the Alcon, but you will be offered tickets for this when you sign up for your registration, which should start sometime in January. We're going to have the after party at a location that's to be announced, not determined. We know where it's going to be, but it will be announced later, probably in January, or probably in January. It's about an hour and a half from Cincinnati. There will be food and beverage and entertainment, which is covered. The only thing that the guests who want to attend this party will have to cover is the transportation, in which we are arranging for transportation for people who want to go to this after party. Doesn't mean you'll have to spend another night in Cincinnati for your hotel, but I guarantee you're going to want to come to this after party. It is in a very special place, and we're going to be very happy to reveal this later. So while you're here, we're going to encourage people just to do other Visit Cincinnati things, and we will work really hard to try to facilitate a great time for everybody outside of the bounds of the Alcon. We're going to provide all sorts of tourism materials, and we may even have some cast member concierges who might guide folks around outside of the normal Alcon schedule. So these are some of the things we're recommending that people do. Again, it's going to happen in August 12th to 15th, 2026. If you want to sign up to be notified when the registration becomes live, you can go to alcon2026.org. Just remember, it's .org, and sign up for the email list to be notified when that registration comes live, which should be in January. And we will, if you want to know more about our organization, the Cincinnati Astronomical Society, you can go to cinastro.org and read all about our organization. And I want to also give special thanks to our Alcon 2026 co-chairs, Laura Zajac and Eric Shermley. They are doing an amazing job of getting this Alcon organized. I can't think of two better people to do this. They're so organized and thoughtful in how we're approaching this. And this is shaping up to be a really great Alcon. So it hasn't happened here in this region for, I think, 27 years, Terry, something like that. So we expect a lot of people within a few hours range who are going to want to come to this Alcon. It's going to be great. So we will see you all here in Cincinnati next year. And if anybody has any questions, I can answer them. Other than that, I'll turn it back over to you, Terry. Thank you.
Thank you, Brian. Let me reiterate on the after party. The after party will be so much fun. Seriously, give that serious consideration on staying. I think it will be well worth it, and you will enjoy it. There is so much going on in this Alcon. It will be so much fun. We will also be presenting some awards for the Great Lakes region. Since it's the first time it has been in our region in so long, we will have a special part in the banquet. So that's another thing to consider too. So thank you, Brian. Scott, I will ask you if there's any questions for him before I leave.
Yeah, I don't have anything right now. No.
Okay, no problem. As he goes on, I'm sure there will be plenty. So, all right, Brian, thank you so much.
Thanks, Terry.
All right, now we are going to get to our presenter tonight. Let me tell you a little bit about Jericho. Jericho is a high school senior, science communicator, member, and contributing writer at the Milwaukee Astronomical Society. He is passionate about astronomy and writing about the heavens above, and he is pursuing it as a future career. His Unistellar eVscope is perfect for imaging and collecting valuable data for citizen science. Some of his 200 citizen science contributions include observing variable stars, exoplanet transits, asteroid occultations, and near-Earth asteroids or comets. Because of his service, enthusiasm, and a collaborative scientific publication for astronomy, he won the 2025 Astronomical League Horkheimer d'Oria Youth Service Award. When he's not stargazing, Jericho enjoys reading, volunteering at his church, and working at a local library to help others grow their love of learning. Jericho, welcome and thank you for being here tonight.
Yeah, thank you so much for having me. I'm so excited to present and say a little bit about the citizen science I've had the opportunity to do. I'll start
Well, thank
sharing
you.
my screen.
Sure.
Okay. Let's see here. See it all good? All right, then I will get started. I just wanted to share a little bit more about myself first, though. For my entire life, I've been interested in the heavens above and pursued it for both simple visual stargazing and reading as much as I could on space. I'm currently a high school senior, and I plan to go into the field of astronomy as a future career. I was honored to win the Horkheimer d'Oria Youth Service Award this year, presented to those who have shown exceptional service to amateur astronomy and to the public. Chuck Allen offered half of his speaking time at AstroCon 2025 in Bryce Canyon, so I could present on this amazing citizen science that has connected me with astronomers worldwide. It was an incredible experience to enthusiastically share my passion with 300 other amateur astronomers over my 17th birthday and receive service and imaging awards. The audience loved it. But in all seriousness, I am extremely grateful for Chuck's kindness and the consistent encouragement of others, and I look forward to sharing my work with you tonight. To start with some examples of my other work, I've been an active member and volunteer of the MAS, or Milwaukee Astronomical Society in Wisconsin, including writing articles in my citizen science activities in their newsletter. They have been a great encouragement in my pursuit of astronomy, and I'll refer to them a few times in this presentation as the MAS. The main method I've used for my data collection, whether it's at the MAS or in my own backyard, is the Unistellar eVscope. Now, the Unistellar eVscope is a digital smart telescope. As an example of differences between a standard telescope and a smart telescope, this image here compares the pillars of creation. So on the left, you see common telescope standard, what you can normally see, observation. And then on the right is Unistellar's 4.5-inch mirror telescope. And the reason there's all that color and extra detail is because the telescope automatically processes a live image every 4 seconds by stacking frames to increase the image quality. It also automatically adds colors that accurately reflect what the object would look like. We could see a broader range of the light spectrum. For some larger telescopes that have a wider field of view, it can take tens of hours to capture the data, not including the additional color processing. Yet after only 10 minutes of data collection, I was able to photograph this nebula, Messier 27, with the eVscope. Doesn't this nebula look like a dumbbell or an apple core to you? Like other motorized telescopes, the eVscope locks onto objects as the Earth rotates, in both daytime or nighttime. This is useful for making sure the image stays aligned as the color is slowly added over time. But it can also be used if you'd like to switch between telescopes at start party or need to do anything else. Before we fully move on to the DIY citizen science, here's an example of some photos I took of the eVscope during the April 2024 solar eclipse and the March 2025 lunar eclipse. And as you saw in that video on the left, I used a solar filter to reduce the sun's intensity by 100,000 times and made a little time lapse of the frames together. This rapid astrophotography processing is a huge game changer for public outreach. As an example of this, I can often ask curious guests if they want to see a cluster of stars, colorful nebula, galaxy. Then, as the telescope automatically moves and focuses on the object, we can share some facts from the Unistellar app, such as the distance to the object, the size, or what elements it's made up of. As the frames stack and the color starts to climb into view, we can all expectantly watch in excitement. And anyone can download the photo right from the Unistellar app. giving the guests the special option to take something home as a memory of their time and as a form of free club publicity if they show others. Another amazing feature for Outreach is a bottom caption showing the object, exposure time, location, and date. You can see here this example of M15, the Great Pegasus Globular, and the glacier moon of Saturn, Enceladus. Just a few more of my favorite photos I've taken includes a stunning full moon, the hidden gem of the fireworks galaxy, and the vibrant Orsted Nebula. There's something really funny that happened during an open house night in my local club that I wanted to share. I was showing the moon to some guests, sharing some facts, and answering any questions when one young elementary schooler came up to the scope. His eyes were really big, he was very curious, and after taking a long look at the moon, he asked me, "Have you ever been to the moon?" And I had to sadly tell him no, but that maybe one day I'll go there, and maybe one day he'll go there too. Stories and experiences like that are the part of open houses I enjoy the most. It's quickly becoming one of my favorite ways to engage in inspiring astronomy outreach. But there's another way we can engage in astronomy outreach, and it's called citizen science. Citizen science is a very broad field, but it is pretty self-explanatory. There are many amateurs in the field of astronomy who voluntarily dedicate their own time and effort to certain projects, something professional astronomers always value. And then with these programs, amateurs aren't a step below professionals in terms of knowledge or competence, but simply those using a different approach, and sometimes observing right alongside them. No matter their background or what telescopes they have, these stargazers can contribute greater knowledge of space in a variety of ways. And at the very end of this presentation, we will also discuss some citizen science that requires no telescope at all. However, I found that the Unistellar eVscope has some certain capabilities to make it a user-friendly telescope option for anyone to pick up and learn. One of the reasons for that is because they have something called the Global Unistellar Citizen Science Network, and I'm personally involved in this organization. So through this presentation, I'll explain how anyone can collect scientific data by sharing some personal examples of what I have observed. Like Terry said, I've personally collected over 200 observations of near-Earth objects, exoplanets, cataclysmic cosmic explosions, and more. After every night of observation, the data is sent to professional scientists who then provide a data graph so they can continue to develop scientific predictions or models. A recent addition to the Unistellar eVscope even allows the observer to download their own data and use the raw files. In this presentation, I'll also explain why any of this is important and why you should care about it, how it is useful. I found that you have a completely different and much more enthusiastic or passionate mindset about something when you can see the bigger picture of something and the deeper purpose, whether that's in science or anything in life. Now, the vast majority of data collected is digital measurements of light's brightness, which is then graphed over time. The higher magnitude level, the dimmer the object is. And if it's over magnitude 6, it cannot be seen with just the naked eye. These light curves are measured on a 2.5 ratio magnitude scale. So, in other words, a magnitude 1 star is 2.5 times brighter than a magnitude 2 star. But a magnitude 1 star is 100 times brighter than a magnitude 6 star as it exponentially grows. Measuring or detecting brightness is actually photometry, a branch of both optics and physics, yet it can still be incredibly simple and rewarding to undertake. The unistellar observation programs aren't just limited to the magnitude of the star's light shining, but also measuring the reflected light of near-Earth objects like satellites, comets, and asteroids, a unique feature of digital telescopes. Satellites are usually powered with solar panels, but this is a side effect of unintentionally reflecting sunlight. While this usually only occurs a few hours before or after sunset and sunrise, as the satellite is then out of the Earth's shadow, it is becoming more and more common to see them. As of this year, there are 12,000 active satellites, and the majority are located at only 1,000 200 miles above the surface of the Earth. In fact, the International Space Station is 250 miles above our surface. With this dramatic increase of satellite launches, it has been predicted that as many as 60,000 satellites could exist in low Earth orbit by the end of the decade. This could create some dramatic problems for astronomy observations that rely on finding faint moving targets like asteroids or any observations that require long exposure times. You can see in the image on the left just how frustrating satellite streaks can be. So because of this, our observations can provide valuable feedback on the magnitude of these objects, so we can help prevent these bright distractions from continuing to stop and hinder professionals. And as a great bonus, you can get a video of a satellite rapidly streaking across the view of the scope. Here's a looped example of my observation of a starring satellite. As you can see, it's going extremely fast, but the telescope can still capture just how bright it is. I even hope to observe an image of the International Space Station soon. Unistellar was recently approached by a private company to observe the effects of one of their satellites, and this could develop into a full scientific paper if the results were effective and successful. Now, another near-Earth object that can succeed and be captured with a telescope does have a big reputation, but in the end, they're not scary at all. They're called comets, and they orbit around the sun. Sometimes they get so close to the sun that their icy body starts to melt, forming a bright tail. Unlike the fellow near-Earth objects of asteroids, which we'll also discuss, comets are made of gas, dust, and ice. The light reflected from the comet's tail doesn't just make a stunning image, but can also be measured by these smart telescopes while the comets orbit around the sun. When the gas and dust in the tail of a comet experience an outburst and increases in brightness, they become targets of interest, so we can discover why this occurs. You may notice something unique about this comet would be the two tails, likely caused by an unequal amount of ice and dust released. Unfortunately, I did not capture a picture of the Millennium Falcon. Here, we can see my spring 2024 light curve of Comet 12P on the left. Similar to Halley's Comet, it fully orbits around the sun every 71 years. So any observation was a once-in-a-lifetime occurrence. This gradual increase in brightness was predicted and then recorded worldwide starting in the fall of 2023, seen in this collaborative graph, with each data point representing a unique observation. Of course, comets are also incredibly unique objects to photograph as they travel across the sky. Just this fall, we were treated to both Comet Lemon and Comet Swan, so please enjoy these images. I think it's important to balance both the data collection and contribution with seeing the wonder of the heavens. Another common object in our solar system would be asteroids, and they are defined as rocky minor planets. Like major planets and comets, they're constantly moving around the sun, but the eVscope can still track these asteroids with no manual telescope movement required. Unistellar citizen scientists have the privilege to observe both near-Earth and main-belt asteroids, and while both groups orbit the sun, their differences lie in where they orbit. Near-Earth objects orbit up to 1.3 astronomical units, or 1.3 times the distance from Earth to the sun, 123 million miles. But the main belt asteroids are farther away and are located in between Mars and Jupiter in the well-known solar system region known as the asteroid belt. Both are equally important to observe, yet for different reasons. Here are some quick examples of the near-Earth asteroids, which are categorized by distance. Although some are closer to Venus or Mars as opposed to us, there are many that can possibly intersect and thus crash into Earth. These are either Apollos or Atens, with Apollos being farther from the sun than our average distance, and Atens being closer to the sun than our average distance. Now, what would you do if one day an asteroid crash landed right near you? Well, on February 15, 2013, a 60-foot asteroid went undetected before exploding midair over a Russian town and injuring 1,500 people. Thankfully, no one died, but the fireball may have been brighter than the sun, as you can see in this video. Now, because of risks like this, NASA asks citizens if an interest in astronomy to help them watch the skies. In the summer of 2024, I was able to join other MAS citizen scientists and Unistellar's global network to observe 2011 UL-21. Here is a video in mini light curve over a 40-minute observation showing this mile-wide asteroid travel across our sky. It has the blue circle around it, and as you can see, it's just going so fast, yet we're still able to capture it with just a 4.5-inch mirror telescope. Now, it missed Earth by a little over 4 million miles, but in space, this is relatively close. 2011 UL-21 is in the top 1% of asteroid sizes. It was among the top 10 largest asteroids since 1900 to have passed within the hazardous threshold of 4.6 million miles from Earth. For comparison, that's about 17 times the distance from Earth to the Moon. The following chart shows every unistellar telescope that observes the asteroid. The bottom data marks the dates from June to August, and although the asteroid could still be detected, it consistently faded, becoming 40 times dimmer only a couple months after it passed Earth. There have been many other successful near-Earth asteroid missions with around one per month. This is one of my favorite ways to collect data because of the unique video and the surprising amount of information that can be learned. So I highly encourage you to give it a try. The purpose of this observation wasn't just to view the reflected light of a close call asteroid, but to provide more information on the rotation of the asteroid and its orbital path around the sun, even after it passed Earth. We can use this knowledge to then better protect our planet from these close call mysterious asteroids that may one day arise. And worldwide observations can be vital, as an asteroid that hits Earth could land anywhere. Information on the orbit is also extremely useful when the professional scientists are attempting to create a three-dimensional model from the citizen scientists' data so they can show the shape of an asteroid. Throughout March and April of 2024, Unistellar challenged eVscope amateur astronomers worldwide to try and collect data of two targeted main belt asteroids. MAS members Matthew Rhino, Dhruva Kalyani, and myself collaborated with multiple eVscopes to track asteroids Impella, which has a 34-mile diameter, and asteroid Isolde, which has an 88-mile diameter. For comparison, Impella is about the width of the smallest state, Rhode Island. On the other hand, Isolde is nearly triple the size, about the same as the width of Connecticut. Both of these state-sized asteroids are in the top 1% of asteroid sizes. After our hard work and persistent observations, both of these asteroids now have a digital 3D model based off the global observations made by citizen scientists. This slide here is Dhruva's light curve and asteroid Isolde. And this next slide is the 3D model of Impella and my specific light curve of the observation. These smooth and constant light curves correlate to a relatively smooth and round asteroid. So why do we do this? Why is this important? Well, similar to the old days of exploring new continents, a geographic mapping of an asteroid provides more information on objects in our solar system, and it could even be useful commercially for interstellar mineral mining. It's even possible that asteroids containing water will be mined to produce rocket fuel for any kind of space mission. It's a new field of planetary science and a new field of study, but it has a lot of untapped potential, especially because these valuable resource reserves can travel right to us if they are near-Earth asteroids. But there's yet another method of observing asteroids with this smart telescope. Asteroid occultations observe an asteroid pass between a bright star and your location on Earth. The telescope's recording of the star's brief disappearance can provide valuable data so astronomers learn more about an asteroid's orbit, size, shape, and mineral composition. This reflected shadow stretches across a long path on Earth. And depending on the observer's location, they will see different results from viewing different sides of the asteroid, similar to the path of an eclipse. And although not every observation captures the full occultation, the data is still extremely valuable. By studying anything you can observe from your location in the asteroid's shadow, scientists can then combine all the collected data from your fellow observers to create a complete result. Now, as an example of a successful occultation captured by the Unistellar telescope, here is a recent recording of my data of main belt asteroid KD Chrysic, with the blue circle focusing on the blocked star. So please take a look. And boom, right there, the star quickly disappears because the main belt asteroid just went in front of it and briefly, for a split second, blocked the light. This main belt asteroid is 6 miles in diameter, which is the same size as the San Francisco Bay, or over 100,000 Big Macs. Because the occultations often last only the blink of an eye, only 13% of all attempted unistellar asteroid occultations in 2024 were successful. But if we can measure minor planets or asteroids that pass in front of a star, could we do the same for larger planets? Not only is it possible, it is one of NASA's main requests for citizen scientists. Planets are defined as objects that, like the star, gravitationally condense into a spherical shape and have no obstacles in their orbit. Currently, our solar system has 8 planets that have met these requirements, and unfortunately, Pluto is not included among them. On average, it's estimated that there's at least one planet orbiting every star in the Milky Way galaxy. That means there's potentially 100 million planets, maybe more, just in our galaxy, and they're waiting to be discovered. So far, there are 6,000 confirmed exoplanets in just the last 30 years of exploration. Similar to the 4 outermost planets of our solar system, more than half of the discovered planets so far are gas giants or Neptune-like. But the number of confirmed planets has skyrocketed even in the last decade, comparable to the progression of smartphones. Unistellar telescopes can observe alongside professional space organizations worldwide as these exoplanets orbit their star. These exoplanets then transit in front of them, partially blocking some of the star's light. As a solar system focused example, Jupiter blocks 1% of the star's light during a transit. Yet our planet, closer to the sun, only blocks 0.1% of the sun's light because it's smaller. Similar to asteroids, these observations then help planetary scientists discover the size and orbit duration of distant planets. Transits aren't just to detect exoplanets, they can also provide some foundational information on distant worlds and set up additional studies in the future. However, unlike asteroids, the unistellar eVscope is not powerful enough to actually capture an image of the exoplanets, instead, indirectly detecting them through the decrease in the sensor star's brightness. You can see with these images that there's a nice, clean U-shaped dip to signify that some sort of object has been detected. Now, transit technique of detecting exoplanets is actually more widespread and easier than direct imaging, with nearly 75% of confirmed exoplanets using this method. Some of these observed planets aren't even counted among the currently confirmed 6,000. Instead, they're possible candidates that require follow-up from Earth-based telescopes. The Transiting Exoplanet Survey Satellite, or TESS, has nearly 5,000 additional planetary candidates. Now, it's undetermined whether these objects are a false positive or a genuine discovery of a new world. So, the time and resources of citizen scientists, such as the Unistellar Global Network, are extremely valuable and can help grow the number of confirmed planets. In early 2023, Unistellar was approached by NASA and asked to monitor targets known as duo transits. While the name may imply discovering two planets orbiting a star outside our solar system, it actually refers to planetary candidates that were only studied twice by NASA, usually with months in between. For this test object of interest, TOI 557101, it had a gap of 731 days between its two observations. It's located 1,000 light years away in the constellation Lynx, and it is best seen for the fall and winter months. And despite some opportunities throughout 2023 and 2024, no usable data was collected until my observation on October 26, 2024. This has been such a unique and incredible opportunity to get involved with professionals from the likes of SETI, NASA, and AAVSO. Since this data, which you can see in the bottom right, has narrowed down the potential orbital periods, it has kickstarted other likely detections seen from Japan and France, and it's currently the featured exoplanet on Unistellar's website. As it is an ongoing research study, there will be more observations in the future, possibly from NASA equipment. But one question I've been asked by some of my friends when I shared this exciting news was if I could name the planet, since I helped discover it. While this would be the cherry on top to such a fun experience, giving exoplanets proper names isn't actually that simple. The International Astronomical Union has contests every few years where names are submitted and they select certain historically significant names. Certain copyrighted names or living people are not allowed. So unfortunately, I could not name it anything like Pizza Planet. But in conclusion, although we are close to an exciting answer, the orbit could still be anywhere between 36 to 146 days. I believe this process of discovery is one of the most interesting and rewarding parts of science. We also collaborate with different organizations for follow-up observations of different planets. Imagine if we only discovered Pluto, then never did any more research. We would be losing out on valuable new information. In 2024, there were 10,000 citizen science missions, not counting the time spent on astrophotography by other Unistellar users. Because there are fellow citizen scientists with eVscopes around the globe, we can continuously observe different events as the Earth rotates, assuming the skies stay clear. Now, a quick question is, how many times have you heard someone say the world's falling apart? Well, we're slowly starting to discover exoplanets that are disintegrating and literally falling apart. Currently, there are only 4 of these disintegrating exoplanets, which is less than a tenth of a percent of exoplanets, considering there's 6,000 others that are seemingly fine. BD plus 05 4868AB, which we'll shorten to BD05 to save breath, is a confirmed exoplanet from professional scientists. So we knew it had a 30-hour transit. Although planets that close to the sun are not found in our solar system, it's common for exoplanets that we discover, and it can cause us to change our theories on planetary formation. 2/3 or 20 hours of BD05's orbit includes the planet covering the orange dwarf star, because there's likely both a leading and trailing tail. Based on observations from larger telescopes in Hawaii, the tail is at least 9 million kilometers, but it's made up of particles that are 100,000th of a meter. Please see the illustrations on the left and the right to try and put this in perspective. As you can see from this collaborative light curve, we reached this conclusion of a disintegrating exoplanet because of the irregular dips and increases. Instead of an evenly flat and linear shape, this is sloped with a more gradual increase back to the default, which kind of implies some sort of tail behind it. with nearly 90 observations over 3 different nights from 56 different amateurs. This was a massive unistellar project, and it isn't finished. I'm so glad I was able to observe each night, especially because I had never heard of a disintegrating exoplanet before this amazing opportunity. Just this October, the James Webb Space Telescope took another look at this planet. The results aren't yet published, but it's likely we'll see a mineral measurement of the inside layers of the planet that have been scattered throughout space. Like the previous exoplanet, this isn't the last time you'll hear of this literally groundbreaking find in astronomy for 2025. As a final example of exoplanet projects, Unistellar launched the UpTempo program, Unistellar pursuing test exoplanet markers previously overlooked, and observed TIC 459-280-861. And although this may sound like a phone number, it was actually theorized to be a giant Jupiter-like exoplanet, as seen on the right. But tests did not have enough time to continue its investigation. So, 10 North American scientists, including myself and the president of the MAS, Matthew Rhino, observed the star in July of 2024. While this collaborative light curve on the left shows a successful detection by citizen scientists, observations from larger ground-based telescopes done by professionals showed that the object was actually greater than 200 Jupiter masses. This means we actually discovered an eclipsing binary star and not a gas giant exoplanet. But this is still great news. Eclipsing binaries are two stars that orbit around a center of mass and can eclipse in front of each other, like those two suns seen on Tatooine from Star Wars. Although they may seem very obscure, with some people unaware that they are a real object, 85% of stars are actually a star system of two or more, which makes our sun pretty unique. Eclipsing binaries are part of a large group of stars called variable stars, which are objects that frequently vary in brightness. It's a very creative name. One famous variable star and binary star is the Blaze star, or T Corona Borealis. And at this point, I think it's starting to become more infamous because so far we have not captured an eruption. It has been observed throughout history, starting with Christian monks in the 1200s, and it repeatedly increases to over 2,500 times brighter, increasing from 10th magnitude to 2nd magnitude. This is comparable in brightness to the famous North Star Polaris. The last outburst of TCRB was in 1946, when a British 15-year-old reported a visual estimation that contributed to the current estimate of an 80-year-long cycle. The binary star system includes a red giant star and a white dwarf star. And not to bore you with complicated star types, but in summary, both these stars are running low on fuel, with the white dwarf fully depleted. In fact, a white dwarf is actually the final stage for some stars instead of a black hole. Now, stars are not cars, so the white dwarf can't go to the local gas station to get fuel. Instead, the white dwarf pulls material from its companion red giant, as you can see in this illustrated video. And once it has enough material, the white dwarf goes nova, which is a thermonuclear explosion similar to an atomic bomb. If we took a teaspoon of white dwarf fuel during this time, it would weigh over 10,000 pounds on Earth, similar to an elephant. Although the red giant is usually brighter, the white dwarf now temporarily becomes the brighter star. And not only are observers worldwide desperately trying to catch the explosion with their own telescope, the information gathered can improve the accuracy of the next estimated explosion in 80 or so years. Here is my light curve amongst the ongoing 2-year-long observing program. Any unistellar observations are sent directly to the previously mentioned American Association of Variable Star Observers, or AAVSO. I have personally observed nearly 18 hours of TCRB starting in the fall of 2023, when I was just starting my sophomore year of high school. And at the peak of this campaign, there were nearly 270 global observations in only 3 weeks just focused on TCRB. So even if you don't have a telescope, everyone should keep their eyes open for this seemingly new star in the sky that will erupt soon for a once-in-a-lifetime event and be visible to the naked eye. Continue that idea of stars that are currently active, let's talk about EE Cephei. It's another eclipsing binary, but that eclipsing part has a unique twist. A ring of remnants and dust orbiting one star can block the light of the second star, causing much longer eclipses. You can see an artist illustration on the right of this extraordinary event. It kind of reminds me of the disintegrating exoplanet mixed with TCRB. Both Unistellar and AAVSO want to catch the beginning, middle, and end of this 57-day long eclipse. We started off observing long before the eclipse, and now we're in the very middle of a twice-a-decade event. You can clearly see a dramatic and gradual drop in brightness from my light curve on the left. Since this event is still technically ongoing, there are no other results to report. But hopefully, we can catch more glimpses of the star after the entire eclipse as it once again returns to the original brightness. Now, there is finally a finished and successful unistellar campaign of star observations. This fascinating unistellar study chose and analyzed 3 stars to determine its brightness and convert it to a Johnson photometric wavelength system. Although it was mostly to test the eVscopes capability for a publication in the journal JADIS, it was still a unique opportunity because it could even kickstart measuring the temperature of stars through citizen science. But wait, there's more. 3 months after the exciting observations, I'd become a published scientist and contributed to my first official scientific study, alongside MAS members Matthew Rhino and Scott Lancel. This was such an exciting opportunity and a true blessing to have such an opportunity when I was only 16 years old. Now, maybe you're in the audience and you're not currently interested in an eVscope, but you are captivated by this unique citizen science. Or you'd like a nice alternative if it's a cloudy night and you're cooped up inside. I'd be remiss if I didn't also share about this incredible website and scientific platform called Zooniverse. Not only is it one of the largest citizen science organizations, it's also one of the most successful ways to engage in this science. The main difference lies in the fact that you analyze and observe data that's already been collected by the professionals, as opposed to the hands-on data collection that the eVscope offers. However, you can still make interesting discoveries, make contributions that have a worldwide impact, and even train and improve machine learning software. In the past, they've successfully mapped craters on the moon with help from the general public, classified the shapes of galaxies, and even observed wild animals in the African safari. That's right, Zooniverse goes beyond just space science. So if there's any other topics that interest you, be sure to check out the wide variety of programs that they have to offer. One of the ones I'll use as an example is the Zooniverse Planet Hunters test program. I know one quick glance at this makes it look very complicated and scientific, but I like to think of it as a pattern recognition game. You draw a little barrier around the decrease in the light's brightness, submit it onward, and then move on to however many others you'd like to view. Because there's tens of thousands of volunteers, the data you just observed will always be sent to someone else. So there's very little pressure of accidentally missing something. You can make posts if you find something you want to discuss or share, and you can even run into seeing some eclipsing binaries, as is common with light curves of stars. According to Zooniverse in March of 2023, the Planet Hunters test project has discovered 15 confirmed exoplanets and 284 exoplanet candidates. I think another way to view this project is a precursor to the hands-on unistellar observations. Because citizen scientists helped the professionals and uploaded their findings to an exoplanet database, they could reach out to other amateur astronomers for more citizen science. Next, we have the Daily Planet, the #1 newspaper of Metropolis and the best place to find Superman. Wait, no, it's actually the Daily Minor Planet. Oops. Well, it's still extremely important and very real. This project uses data for one of the most effective surveys of the sky from a telescope on a mountain in Arizona. Since 1998, the Catalina Sky Survey is a NASA-funded project that has discovered over 160,000 near-Earth objects and even some main belt asteroids. These cameras take 4 images of the sky every 6 minutes. Then they create an animated GIF of the result. If there is any motion, a computer algorithm will detect it. But then humans must check whether this motion is a real object or a false positive. Because it observes so much of the sky so very often, it desperately needs some human oversight. Fortunately, this isn't just limited to professional scientists, and anyone interested can participate in this massive project. If the circled object disappears during these frames, then it was simply an artifact. Occasionally, Zooniverse will give you feedback based off your answer as a way of encouragement and keeping you engaged. All right, let's take a quick crack at this. As an example of both a positive and negative detection, take a look at this video. The object with the green circle is clearly an asteroid. But what about that dash towards the left side of the video? Well, we can't see it continue on to another area of the sky or appear in other frames, so I personally would say it's not an asteroid. But again, we can submit this to other people and they can give their own feedback and advice. In conclusion, Zooniverse projects are very easy to understand and invest your time into, and I would highly recommend it for those who are just starting their interest in citizen science. I think it does a great job of simplifying the data, making it a fun challenge, and giving everyone of all ages an alternative way to make discoveries. Another scientific lesson that we can learn from this is that collaboration and multiple people are always needed. Trustworthy scientific papers are peer-reviewed and often contain many authors. Any of these citizen science examples require multiple detections, so we can fit these puzzle pieces into a completed answer. Remember, once you see the bigger picture and deeper purpose, it's much easier to channel your enthusiasm and passion into a project. We started and concluded this presentation discussing how anyone, no matter their background or expertise, can contribute to science. As a historical example of this, I'd point to William Herschel, the first person to truly observe the planet Uranus in 1781 and discover it was actually a planet, not a variable star. Although he later became the first president of the Royal Astronomical Society and achieved much more success, he was just a middle-class church musician with a hobby and a telescope before his rise to fame. I'm in the middle of my senior year of high school, yet I've already been blessed with so many unique opportunities. I've become inspired by my faith and lifelong passion to discover more of the unknowns in space. And I hope you also grow your interest of creation and the cosmos. I never expected when I first started to learn this digital telescope that I could be contributing work alongside SETI, NASA, the ESA, and AAVSO. The global Slack channel has truly encouraged collaboration and connected me with fellow scientists worldwide, both professional and amateurs. The active citizen scientists of the MAS have formed a Team Wisconsin so we can stay connected and share opportunities or results of observations. I'm truly grateful for them and more citizen scientists across the globe for the encouragement. You might be asking yourself why I would be so intrigued and captivated by this field of study that I would pursue it professionally. Well, the renowned philosopher Plato once said, astronomy compels the soul to look upwards and leads us from this world to another. Similarly, I sincerely believe that astronomy is a great tool for all to realize that there is more to life's purpose than just earthly pursuits, and that everyone is incredibly unique and important, even with these vast heavens above us. Thank you for listening.
Thank you, Jericho. My gosh, that was an amazing talk. But
Thank you.
what you have done and shown us what can be done is really inspiring. You have
Thank you.
you have really amazed a lot of people, including myself. There is so much information there, and you've went at it with such enthusiasm. And you
Thank
have
you.
shown what can be done. I'm sure you are inspiring so many people right now with everything you just showed us. Thank you so much. So I
Thank
will
you.
oh, you are so welcome. Scott, is there any questions that you have on your end? Or
People
any
just saying
questions here with,
fantastic presentation, and um, you know,
I'm so glad
yeah,
you guys had me.
just
This is really fun to
yeah,
do.
yeah. I mean, it's a very thorough presentation as well, and I think that many people will be inspired to, uh, if not get like a Unistellar telescope and do it like you're doing it, to definitely sign up with Zooniverse and
Yeah,
start doing some citizen science.
nice. I'm so glad to
all
hear that.
all of the
Yeah, I hope they do
information
too.
there is so helpful for people that have ever even thought about this, and you have shown what can be done. I mean, and I'm sure you have a lot more ahead of you that you want to do, but my gosh, you have done an amazing job.
Thank you.
It really is. So, Don or Brian, any questions here that you might want to ask or comment?
Well, I just wanted to say we're looking forward to having you at Alcon 2026,
I'm looking
especially.
forward to being there.
Yeah, it'll be
Yeah,
fantastic to meet you in person, especially with our club's renewed interest in citizen science over the last few years. This your speaking will certainly inspire the guests of Alcon, among which are probably going to be many of our members. So, really looking forward to having you here next year.
thank you. Yeah, I'm looking forward to being there. It looks like it'll be a great event.
Will be. It will be so much fun. Jericho, you ought to try to stay Sunday too, if at all possible. I don't know when
Hmm.
you're coming in, but that event will be a lot of fun. So everybody out there consider it. All right. If there aren't any questions, one thing I would like to do, and I am getting ready to share my screen real quick, is show you we will be back on whoops, I just did that. January, I know it's here behind my, hang on just a minute. There we go. January 23rd. And we will have William Gadamoller, and he will be speaking about new challenges to our model of the universe. And William is also another Astronomical League winner for the Youth Awards. And I'm sure he will tell you all about that. And we are really looking forward 2 months in a row having people, the youth, they're not kids. I mean, these are young adults that are doing amazing things and have really are dedicated to it. I mean, completely dedicated. It's such a good way to start out and so inspiring to people of all ages to see this. So please join us on January 23rd. Next month, we will be back with William. And
Yeah, if I make a quick add, William's actually a member of the Milwaukee Astronomical Society as well. So I know
is
William,
he?
and I will definitely be in attendance for this presentation. I'm excited to see what he has in store for us.
Yeah,
Well,
so
that's
MAS is
fantastic.
just an incubator for young scientists. It's awesome.
Yes, their club and Matt Rhino has done an amazing job. He has been at other or not at Alcons. I ran into him at one of their conferences in their region, and he is an amazing teacher. He really teaches a lot. People just excel around him. So the Milwaukee Club is just an amazing club altogether with their members and what they do. So we will be glad to have William here, and we are sure glad to have you here. And thank you again, Jericho, for everything you did tonight. And I would like to thank Brian Simpson and Don Knabb and John Goss for everything they have done, not to forget Scott. Scott, we couldn't do any of this without you. We appreciate all of the broadcasting you've done, and I'm sure you will be at Alcon 26 doing some live interviews.
Definitely plan to be there. Yep.
Yep. You might see Jericho again because I know you interviewed him last year too.
I did.
And
Yeah,
hopefully
I
we
just
know
watched it
Brian
again,
will be
so,
there.
yeah.
I hope I'm there.
You better be.
I would say by January 23rd, the next AL Live, we will have a lot more detail on the Alcon 2026. We should probably be, if not earlier, but around that time at the very latest, have the registrations available for people to start signing up and have all the details about the itinerary, all the different activities we're planning around it, and more information about the after party, which I think everybody's going to take a huge interest in.
Definitely. Definitely. Well, thank you, Brian. And Don Knabb, thank you again, too. And hopefully we'll see everybody on the 23rd. And Scott, I'm going to turn it. Oh, and thank you, everybody out there that is watching. We couldn't do this without all of you that watch, too. Yeah. And the speakers, the people that have came to speak on this program have just really opened our eyes to what can be done. So, Scott, I'm going to turn this back over to you to close out, and thank you very much, Scott.
Okay. All right. Will do. All right. So we have, we had a great talk with Jericho and Brian and Don, and of course, Terry. And it's always a pleasure for us to be able to present the Astronomical League live programs. And it's also been an honor for us over all these years to participate in their award programs and all the rest of it. But there's nothing like the League in the world. They embrace the community of amateur astronomy like no one else, and they've been doing it for 75 years. So if you're not already a member of the League, you need to join, and you can do it with an astronomy club that's already a League club, or you can become a member at large. And so and that's good for anyone anywhere in the world. So anyhow, I'm going to wrap up this particular program with a little 10-minute presentation from NASA, and it's all about black holes. We're learning more about them all the time.
Black holes are wild. Yes, they are the most compact things we know of, so dense that even past a certain point, light cannot escape. Even though we can't see inside them, the environments around black holes are brimming with bizarre activity. There can be a corona of hot electrons that occasionally spits out scattered X-rays. There's a bright accretion disk of gas and dust whose light is so warped by gravity, you can see the near and far sides at the same time. And I can't even begin to wrap my head around this estimate. There can be jets 20 million light years across. That is 140 Milky Ways end to end. So if we can't see black holes themselves, we need other ways of understanding them, like these extreme surroundings. That's why NASA continues to create new instruments to decode the chaos. So is there anything common about a black hole environment? Let's break down what we know. How does that process happen? How we know it? Where do you start with this? What am I looking at here?
If you look closely, it's a big mess.
And why we need to keep the questions coming. This is Black Hole Environments Explained. Not all black holes are the same or even chaotic. So scientists currently categorize black holes into 4 types. There are the ones that we've theorized exist, like tiny primordial black holes, which formed shortly after the Big Bang, and intermediate mass black holes that are sort of missing in the sense that they should be there, but we haven't confirmed sighting. We've observed plenty of stellar mass black holes that are at least 8 times the mass of our sun and the leftovers of supernovae. The most dramatic by far are the supermassive black holes, which are hundreds of thousands to billions of times more massive than our sun. In fact, they can reach sizes so big, they can span our entire solar system. When they're at the centers of galaxies, these monster black holes can become active galactic nuclei, or AGN. They fling a lot of material, and they produce a lot of kinds of light. AGN are black holes at their wildest. Jenna Kan researches black holes and their signatures here at NASA Goddard. She agrees that AGN are the drama queens of space.
I would call them the divas instead, but when you have an AGN, they want you to notice them as much as possible. So they're singing at every single wavelength they can.
But if you're looking at a full galaxy, do you almost just assume that there's a black hole there?
When we have a massive galaxy, something that is like 1 billion times the mass of our sun, we can pretty much safely assume there's going to be a black hole in there. When you get to the low mass galaxies, which are the ones that I like studying the most, we don't know what's going on in them. But when you have a low mass AGN, that light can be easily overshadowed by stars and everything there. So you really need some kind of unambiguous, stars can't mess around with this diagnostic.
Where do you start with this, right? You get a map of dots. And these dots mean what?
What we'll do is we'll take a spectra of our galaxy, and if we see highly ionized, high energy features, that's good evidence that there's going to be an AGN there.
Would you say that this is the best indicator of a black hole?
That is very contentious. There is no one best option, basically. Every single tool that we have right now is fallible in some way. It doesn't work in some environment.
Enough talking about this environment like it's all uniform. We need a lesson in AGN anatomy. An AGN can have several different structures. The brightest feature is the accretion disk. In this Event Horizon Telescope radio image, we see the accretion disk around a supermassive black hole called M87 star. This plane of gas and dust orbits the black hole and heats up through gravitational and frictional forces. It emits light all the way from radio to X-rays. Above and below the disk, an AGN can have a corona. This superheated plasma of loose electrons emits a lot of X-rays. It's way less dense than the accretion disk, but way hotter. For a long time, scientists wondered how the corona formed, how it was shaped, how it interacted with the rest of the environment. So a recent study with NASA's IXPE telescope shows that the observed coronas likely extend in a plane like the accretion disk and possibly are a lot larger than we previously thought. One of the best methods to learning more about these systems is through analyzing something we call coronal lines. Now, Jenna uses spectroscopy to investigate coronal lines in AGN spectra. Yes, they look like squiggly graphs, but they tell us what elements are present and, more importantly, what isn't present. So a lot of the elements are ionized and are missing their electrons.
So these are highly ionized emission lines. 6 electrons have been removed from that iron atom. It's very, very bright in the center, which makes sense. That's the nucleus, that's gonna be the brightest there, and then it gets dimmer and dimmer as you go farther out. And they're pretty good evidence to there being an accreting black hole in there, because it takes a lot of energy to even produce the ions that produce this emission.
Despite AGN being some of the brightest objects in the universe, they can also sometimes hide behind a dusty torus. Now, a torus is a thick bagel-shaped structure that is so dense we can't see the AGN unless the bagel's hole is facing one of our telescopes, or you seek the energetic X-ray signals. Now, scientists using NASA's NuSTAR mission, another X-ray telescope, think that as many as 50% of black holes are obscured by a torus. These dusty cloaks can even impact a developing galaxy. A lot of that thick debris will make its way towards the black hole, and if too much of the dust falls towards it at once, it can cause the black hole to sort of cough or burp, and a bunch of material comes out. And a hiccup that is big enough can even slow the rate of star formation. All of that is nothing compared to the achievements of a jet. So remember M87? Here's another image of it taken by our Hubble telescope. See that? That bright line is a black hole throwing a huge jet of particles, moving at nearly the speed of light. It does make you wonder. If black holes gather everything that comes too close, how does it propel particle jets? Cecilia Schirenti, an expert in math, physics, and the wonders of black holes, has some ideas how. So what is going on? Why are they ejecting a lot of things when it seems like what we know is that they suck things up?
If you look closely, it's a big mess.
If you have never seen it before, you have to imagine that the black hole is in the center. The accretion disk is around it. Kind of think about, the rings of Saturn that are around the planet. You have this big accretion disk around the black hole. And the jet is coming out like that. So you can think of a garden hose, and it's spraying out there in the cosmic distances, right? Like really big. The matter in the jet has to be coming from somewhere. So it's coming from the disk. And the question is, how do the particles on the disk, how do they get accelerated, pulled out from the disk, and directed outwards on the jet? So that is the mechanism that people try to study, and we have some ideas of how that works. Because if the black hole is spinning, you can steal a little bit of that rotational energy of the black hole and give it to something else.
Cecilia went on to explain that these jets also form because of a black hole's magnetic fields.
With the magnetic fields, what happens is that they are stealing a little bit of the energy, the rotational energy from the black hole. This extra energy in the magnetic fields is what is accelerating the particles in the disk to form a jet. Then it's kind of like the particle accelerators on Earth, where we use magnetic fields for accelerating particles.
Well beyond the black hole, the jet, the ionized and the energized particles, the X-rays and such, the gases just continue to spread. Because of their very nature, we will never see beyond a black hole's event horizon. We are doomed to see only the light that surrounds them. But there's still so many questions we can answer with that light. And with each new telescope we build, whether it peers through our atmosphere from the ground or studies the cosmos from space, they give us more clues as to how and why black hole environments behave as they do.